In 1950, in a landmark essay titled Computing Machinery and Intelligence, Alan Turing asked a simple yet radical question: can machines think? That single question opened one of the greatest intellectual journeys in human history, reshaping science, philosophy, and our relationship with machines. Yet 76 years later, in 2026, a far more unsettling question emerges. Why do we still need machines to think when they can already outperform us at statistics? We now live in an era where logic is no longer the sole foundation of intelligence. Data, billions of examples, and trillions of probabilistic calculations is rewriting the rules of programming. This is not merely a story about technology. It is the quiet history of a 70-year coup, where humans shifted from machine operators to training material for machines. From the 1950s to the 1970s, AI was dominated by symbolic AI. Thinkers like Herbert, Simon, and John McCarthy believed human reasoning could be encoded as formal logic. If humans think through language and symbols, they argued, then teaching machines syntax and rules should allow them to understand the world as well. Early systems that solved math problems, played chess, or proved theorems showed impressive results, but only within tightly controlled environments. The moment these systems encountered the real world, everything collapsed. A machine could prove the Pythagorean theorem yet fail to recognize a cat on a table. Why formal logic demands precise definitions for every concept? Reality, however, is messy, ambiguous, and full of exceptions. How do you define a chair? When a log, a rock, or even a stair can all be used for sitting. Symbolic AI fell into a classic philosophical trap. It understood the word chair, but never truly saw a chair. This deadlock persisted for decades, leading researchers to call the period the AI winter, a long freeze in artificial intelligence progress. AI's revival did not begin in laboratories, but on the internet. In the 1990s, the global network unexpectedly created something no scientist had dared to imagine: a massive archive of human behavior, image, language, and knowledge. By the early 2000s, a fundamental shift occurred. Instead of writing rules for machines, humans began showing machines examples. If symbolic AI was a philosopher's school, then machine learning became the school of lived experience. A cat recognition model no longer needed definitions of ears or tails. It only needed millions of cat images to statistically extract patterns. The explosion of big data transformed computers into a new kind of entity, one that may not know why, but always knows what. Like a child who cannot define pain, yet learns to avoid fire through repeated experience. The trade-off was clear. AI became a black box. The more accurate it grew,
the new data set is definitely
the harder it
improving the model's
became to
performance.
explain. This was the price of abandoning logic knowledge without clear causality. Artificial neural networks first appeared in 1958 with Frank Rosenblatt's perceptron. But limited data and computing power doomed it to obscurity. The turning point came in the early 21st century, when two forces rose together: GPUs and the internet. Graphics chips, designed for pixels, proved ideal for matrix multiplication, the core operation of neural networks. At the same time, the internet supplied billions of data samples, serving as raw nourishment for machine intelligence. Stacked neural layers learned different abstractions, edges first,
It's
shapes next,
restructuring itself
and
faster
finally,
than the
concepts
model
like
predicted.
cats,
We are missing
faces,
something fundamental
or emotions. This mechanism loosely mirrors biological nervous systems, where millions of neurons connect to detect and abstract information. The resemblance inspired the term deep learning not because it is wise, but because it reaches deep into data structure. For the first time, machines no longer needed formulas. They needed experience. Modern AI was not invented by a single genius. It emerged from the resonance of two exponential curves, hardware and algorithms. Moore's law doubled processing power every 18 to 24 months, while algorithms steadily reduced training time from months to hours. In 2012, The AlexNet model surpassed humans in image recognition, a historic milestone. From that moment on, AI ceased to be an experiment and became an industry. Today, data centers run by NVIDIA, Google, and OpenAI consume as much electricity as small nations. Yet they produce no physical goods. What they produce are predictions. Artificial intelligence, in the end, is not the triumph of a supermind, but the inevitable result of energy, silicon, and data converging. A logic machine no longer runs on commands, it runs on probability. If symbolic AI was born from philosophy, believing the world could be reasoned through logic, then machine learning is born from empiricism, believing the world can only be understood through data. Modern AI no longer learns the meaning of actions. It learns their patterns. Human history, shopping habits, medical records, articles, and searches becomes training data for predicting the future. When the past turns into data and the future into probability, the boundary between understanding and imitation dissolves. The end of programming power, therefore, marks the beginning of a new intellectual order. A world where humans no longer teach machines what to do, but instead struggle to understand what machines are learning from us.